what we can, if you write here 2 plus 2, you can obtain 4. But this is powerful too, as I say. If you write f equal 1 plus x, then you can see that this is indeed 1 plus x. But then you can write, for example, g equal f in the power 3 and multiply by y plus 2. And now you see the result. It is such formula. So it is not y but e. Let's correct it and write here y. Okay, now it is y. What else? For example, if you want to obtain integral from this function, how you can do it? In the left sidebar, you see a lot of such fragments. Now you want to find what kind of functions you can use. Here it is, you can see integral function f by the x. Here it is. So you must write here such function. For example, h equal integral from g. And what is the result? Here is some result. What is backward procedure? We want to obtain differential. Differential and integral is inverse operation. So you can add, for example, another windows and try to obtain differential. Here it is such function. The name of the function is h here, and so you can obtain differential from this function. And now you want to obtain the initial formula. The initial formula was very simple. How you can obtain the initial formula? We have a special function. You can ask, please do factorization. How we can do it? Here it is such function, factor. If you try to do factor from W, we obtain the result. You see the same result that it was at the beginning. So I demonstrate you very simple to do very many operations. Simple and not very simple. And this tools has some nice picture. You can do plots, for example, or you can do plot like this. Here it is. What's the plot? It's a function, 3 rectangles, x plus 1 plus 2 lines. Where is the line? X plus 5 and 3x plus 5. This is 2 lines. If you want to make it more nice, you can change the thickness of this line from 3, for example, up to 7, and make a plot. Now you see another plot. If you want something changed here, for example, you want to change this function or something else, it is very easy to do and to obtain another results. This is example for another function approximation. What is the example? You see here some table. The first row is x, the second row is y, and we want to obtain the approximation function as a polynomial of the power 4. You see here number 4. The approximation function you see here. The result is such polynomial. And then we ask, please make a plot from polynomial p. This curve is a plot from polynomial, and t is a table plot from this table, from this function that obtained as a table plot. And then you can see in one sheet these two plots, and you can do much more. Other maybe interesting to demonstrate the 3D plots. 3D plots you can obtain here. You can see an examples. This is some surfaces. That is equation of the surfaces you see here. You can change these equations, or you can change the box. This is minus 10 plus 10. This is how the variable x has distance, variable y, variable z. So there's some box where you can see this figure, and you can change this formula and obtain another one surfaces. And now the example you can see here what this this is some what is it, some parabola. Maybe more interesting here we can see intersection of two plots. Yes, here it is. You can see two plots of 3D and intersection, and you can see the line at the intersection of these plots. And so very many another interesting things you can use here, but maybe I can explain it more carefully if I will have more time. Now I demonstrate how we use these tools for doing our lectures, and how we can study online and offline using these tools. I prepare a little piece of the lecture, and now I have possibility to import text and to save text. If now I push this button, all this text I can obtain in my laptop, and if I push this button, import text, then now I can load my lecture. Here it is my laptop. Here it is downloads folder, and what Mathpartner example takes there, and I select this folder, and I push this button, and you can see a lecture. This is some lecture material. You can see this is in very nice form, because it is like PDF form. Here it is the initial text written in form of LaTeX, because mathematicians and physicians, physicists, very good known this language LaTeX. And if you push this button, you obtain such a nice form of the lecture, and student can understand this text, to try to understand the theorem. It is some theorem we call it China reminder theorem. It's part of the some algebraic computations course, and the theorem students understand how you can use this theorem for some task to read and to understand. But the most interesting part is this part, because here you can see an example for this theorem. What is the example? What is the task? We want to obtain some number, and we know that they have a residual 3, 2, and 1. If your unknown integer number moduli 5, 3, 8, and 3 has residue 3, 2, and 1. And the question is, what is a number? What is a lowest number maybe exist with such conditions? And here it is some formula using which maybe obtain result. But the most interesting thing is that this is not some only formula. This is really operators. This is real numbers, and this is a real answer. What is step by step doing? First of all, this is name M1, M2, M3. Obtain these numbers, and the same with R. Then we obtain multiply of these three numbers and code M. Then we obtain another three numbers, capital M1, M2, M3 in such form. And then we use some function mod inverse by modules, obtain three numbers N1, 3. And this is the last step. We have to do such multiplication and take the modular M. And this is the result. If you want to see at each step what has happened, you can try to print this number and you can see what has happened at each steps. Let's try to do it. I can change here and I write here print. And what number do you want to see? For example, M1 and 2. Is it okay? Yes, you can see N1 is 4, N2 is 7. So you can try to see more numbers, N3. What we need more? We need more M and R. To see here. Here it is M, and here M. And it would be interesting to see what is M. What is M? And what is the result? The result is A. Maybe B now. Now you can see here all these numbers that we obtained in this computation. And you can check that indeed, if you compute such sum of such product, and then take it modulo M is equal 120, you obtain the number 58, and the number 58 is a list integer number that has such property. If you try to obtain by modulo 5, you can divide by 5 and obtain the residue 3. Indeed, divide 58 by 5, you obtain the residue equals 3.